All right, guys. So for this one, here we have a pyramid. So first, I'm just going to describe what a pyramid pretty much is. So obviously, you've heard of pyramids. The Egyptian pyramids, and I think there's this like sporting store somewhere. I don't remember where it's at. But it's in the shape of a pyramid, right? The whole point pyramids, you guys know what they are, right? Looks just like that. Um, Basically, a pyramid's gonna have a base, but just one base, just one, right? Prisms, cylinders, they have two. Pyramids only have one base. And then you're gonna have a whole bunch of triangles that converge on one point called the vertex or the apex. Okay, so that's how you're gonna know you have a pyramid if everything meets up at one little point. Okay, and that you have triangles. Don't confuse it with a cone, obviously. But yeah, okay, that's what a pyramid is. So a few little things you're gonna need to know. Okay, you could see just by looking at our formula, the lateral area formula and our surface area formula. And again, these formulas, guys, are provided on Teams. If you just go to the geometry class and then just go to files, and it's going to be right here, star geometry formula chart. And right now we're doing surface area, so the formulas will be here. I'm going to zoom in so you could see them. And again, we're right now dealing with pyramids. Keep in mind it's the second one. I'm going to move it and you won't be able to see this anymore, but it's the second one. And you see here how under lateral we have that 1/2 P times L, and under total it's the 1/2 PL plus B. The interesting thing here, guys, is, and again you could see in our formulas here, that height is not used at all. The overall height of the pyramid is pretty much irrelevant when it comes to calculating these things. So if they gave you a number here, I mean, you might use it, but you won't use it in the actual calculation. Instead, what our formulas use is the slant height. So your slant height is literally, in its name, it's the height, but the slanted height. It's the height of one of the triangles right there. Now, most of the examples we're going to be doing, guys, they're going to be with regular polygons in the bottom. Okay, exception, of course, like a rectangle, but most of them will be regular. But again, this doesn't change anything. It's going to be your slanted height. Okay, now the interesting thing here is, and I hope you see this, that when you have your slant height and your actual height of the pyramid, when we connect them, we create, and you could already see here on the picture, we create a right angle. So you'll be seeing some problems where potentially they're not going to give you information like your slant height, but because you know that there's a 90-degree angle here, you will be able to calculate slant height using Pythagorean theorem. Okay, again, so that's key to keep in mind. The P, guys, still stands for perimeter of the base. L, again, is your slant height, which, if you don't know it, it is possible that you're going to have to do Pythagorean theorem. Your total surface area, again, you notice that this is just your lateral area, plus B. Now, unlike our prisms and our cylinders where we had 2B, this one doesn't have a 2 because there is only one base. That's why it's just plus B. And again, big B is area of base. So let's go ahead and look at some examples. Now these shapes, guys, they were a little bit more harder to draw. And now that I think about it, would have been nice if I would have thought of this before instead of having you guys draw them. I mean, instead of me drawing them. But I went with the route of just finding some pictures and printing them out instead. I think that's a little bit easier. Now, for those of you guys that are intrigued on how to draw them by hand, because you're going to go ahead and draw them on yours, I would suggest to first start with the picture in the bottom, your base. Like if you wanted to do a square, if you wanted to draw that one, right, you would, draw a square. Let me do it here. Draw a square, and I guess first draw it dashed. It will help. Later you could decide with what will the solid lines be. The dashed lines basically represent what's behind it, okay? And then just pick a random point. And again, here I kind of just gonna do it over here. You're gonna pick a random point where they're all gonna converge to, and then just start connecting the corners to it. Okay. So again, we could just go like this, then like this, and then like that. Okay, and there it is. And again, we could just go ahead and make these. We could either make these solid or those solid. Doesn't really matter. And you see your overall figure. But yeah, a little bit weird to draw these. That's why I went ahead and just printed them out. Alright, so let's start with the basic one. Let's start with one where they give you everything. Okay, let's say this shape here in the bottom was a square. And you knew that this was 3 and that this right here was 4. Okay. I guess it's not a square, it's a rectangle. Alright, let's just say it's a rectangle. And they were to give you the height, the actual height here. And they told you that the height was, I don't know, 10. And again, you're being asked to find the total surface area. Well, remember that total surface area is your lateral area plus your base. But in a pyramid, our lateral area was 1/2 times the perimeter of the base times my slanted height, and what B was just B, right, which is area of the base. We need to know L, our slanted height, and our slanted height is this one right here. Okay. Again, remember how your height goes to the center of the figure. We create a nice right triangle. This distance right here, if you think about it, if this is 3, you would expect all of that to be 3, but your height's right down the middle, so it's going to be half, so it's 1.5. So in my right triangle, I'm going to go ahead and color code it here. In this right triangle that we see, this is 10, this is 1.5, and this represents my slanted height. So again, I'm going to do Pythagorean theorem, and I'm going to go ahead and add. So Pythagorean theorem, which is 10 squared plus 1.5 squared. Whoops. So I find out that my slanted height is 10.1. Okay. I know in this case you're like, sir, the answer was, so close to 10, will it make a difference? And honestly, on some problems, it might not, because the answer will be so close. But you always want to make sure you're using the slant height, okay? Because if this was a much bigger number, you would actually see the difference, and it would no longer be the same. So please make sure, don't take your slant height for granted. It will give us different answers. All right. So again, and basically, if you end up using the height in this formula, your answer will be wrong. Okay, so make sure you find your slanted height. This is 10.1. All right, so now let's just go ahead and substitute. So it's 1/2. My perimeter, let's not forget about the perimeter, 3 plus 4, right? And then there's another 3 and 4. So that is a total of 14. Just put somewhere here that the perimeter was 14. Okay. times my slanted height. And then we need to find the area of the base. But again, we've been doing these, so you guys should be able to tell me right away that because the base is a rectangle, it's just 3 times 4, which is 12. Now we just come here, we plug everything in. 1/2 times 14 times 10.1 plus 12. So we get here that it's 82.7. My surface area is 82.7. It's that easy, guys, that easy. Again, the only thing you're going to have to look out for these problems is this Pythagorean theorem deal. That's pretty much it. All right, let's go ahead and do one more example here. This one, I'll make it so that we work backwards on it, I guess. We'll try that one out. Let's say that in the bottom we had obviously the shape here in the bottom, the base, is a triangle. So when we're looking for the area, it's going to be area of a triangle. Now let's just say that the following were the numbers that I gave you. Let's say that I had already given you the slanted height, and that the slanted height was 10. Okay. Let's say that these two sides were the same and that they were 12s. Okay. And that the bottom part was, just say it was 20, the side and the back. Or you know what, let's just make it into an equilateral triangle. There. So let's say everything in the bottom was 12. Okay. And honestly, that's it. So with that, you should be able to find everything. So again, surface area is 1/2 perimeter times slanted height plus b. In our triangle, we can easily calculate the perimeter to be 36. And when we find the area, we'll just keep in mind that it's 1/2 base times height. So here you're going to have to draw your height like we've done before, right? So we work with this right triangle that's in here, where this ends up being 6, and we do Pythagorean theorem. Again, Pythagorean theorem is going to be used a lot, so make sure you know when and how to use it. So it's 12 squared minus 6 squared. So I find out that the height of this little triangle right here is 10.4 basically. And when I want to find my area, it's going to be 12 times 10.4 divided by 2. So the area, which is the base, is 62.4. Alright, so now I just plug everything in. I know my L was already given. L was 10. So it is going to be 1/2 times 36 times 10 plus 62.4. 1/2 times 36 times 10 plus 62.4. So the surface area is 242.4. That's it. Okay, let's see how long it's been. Okay. And again, guys, that's all it is. That's how you use the formulas. I have one more example here. Again, I already showed you how to find the slant height. If they only wanted lateral area, well, you would only focus on this first little part. Here we go. This is also a pyramid. The base, just by looking at it, there's 1, 2, 3, 4, 5. Your base is a pentagon. So this is called a pentagonal pyramid. So again, 5 sides, 1, 2, 3, 4, 5. And I'm just going to go ahead and tell you that this is supposed to be a regular pentagon so that you know that all sides are the same. In this problem, let us say that you're given, let us say that you are solving for your slanted height. Okay, I think we should be able to do that. So let's say that your surface area was 500, whatever, 500 meters squared. Let us say that you knew that each side in your pentagon was 6. And let us say that the apothem, just to keep it simple and we don't have to solve it, let's say that the apothem was 8, or yeah, let's just say that it was 8. Again, it's an actual number, but for now, for practice sake, let's just say it was 8. Okay, and you are supposed to solve for find your slanted height. Well, again, according to the formula, it all goes to the formula. So first you look at the picture and you're like, oh, it's this shape, it's a pyramid, surface area. I know that surface area is 1/2 P times L plus B. In my pentagon, I can easily find my perimeter. If each side is 6, my perimeter is 30. I can easily find my area because we were given our apothem and now we know our perimeter. So our area, which is B, is basically 30 times 8, in this case, divided by 2. If you don't know why I'm using this formula, go back and look at how to find the area of regular polygons. And now I just substitute everything I know. Again, surface area was 500. 1/2, my perimeter is 30. I don't know what L is, I could call it X. And big B is 120. And we just work it out, algebra, right? So 500 is equal to, that's 15 times L plus 120. And again, it's just a matter of moving the 120 to the other side. And then dividing by 15. So again, from here, they could ask you anything. They could have actually asked for you to find the area of the polygon. They could do anything. But if you know your algebra, if you know your formula, you'll be fine.